it's a plane in which all particles will have same phase. The light is propagating like this. So let me choose 2 points like A and B. So what is it? This is a medium one. Refractiveness mu1, and it will propagate with a speed v1. So here both these particles will have same speed. So what is Va equal to Vb equal to v1? When the same particle arrives here, it will enter into medium 2, refractance mu2. So here speed is how much? V1 equal to c by mu1. Here v2 equal to c by mu2. I'll say this is a rarer. Then what we can say? V1 greater than V2. Now look at the particle B and D. Now the B has entered into the medium. So what is the speed of this? Will become V2. And the A is yet to enter into medium 2. So it will have a speed V1. So now what will happen to the wavefront here now? The point B on the wavefront will have less speed than this in a given interval of time. The wavefront here will be like this. So in a given interval of time, the V2 is less than V1. So in a given interval of time, the point B of a wavefront will cover less time than the point A on the wavefront, less distance. You calculate this one. So this is V1 greater than V2. In a given interval of time, the A will traverse more path than B. Okay, let me put it in this way. Then afterwards, both A and B will enter the same region. So then both will have same speed and the wavefront again will become parallel to each other. So here it will propagate with a speed v2. So the entire discussion what we have to do is like here at this particular point we have to do it. Here the point B will have a speed v2, whereas this will have a speed v1. In a given time, the A will cover more distance than B. So here the distance covered is less, here it is more because the speed is v1 here of the point of the wavefront. Here the speed of the point B will be, the point B will lie in the now denser medium. It will have less speed. So in a given time it will traverse the less distance. So therefore the wavefront will bend. This is the equation what we can give. If you are talking in terms of the wavefront, if you bring the idea of the wavefront, no, yes, you analyze in this particular way. I'll give in detailed diagram. So some of you may find this very difficult. There's a wave it has entered. It is like this. Same thing. I'll magnify the diagram. That's all here. So you can see clearly now both will have same speed. Now also both will have same speed. Now very next moment you can see that it is going to have the speed v2. So the wavefront will bend. Then also you can see that. No, again, okay, no problem, that one. They will have same speed. This region is something very important. Here, what is the speed of the wave? Point B and A will be same. Now will be same. Very next moment, the speed of B will be less compared to A. In a given interval of time, this will cover more path, this will cover less path. So therefore, the wavefront will bend. This only I just magnified it. V1, 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 V1. It will be V2, V1. V2, V1. Now V2, V2. So V1 greater than V2. Getting the idea? So why the ray of light should bend towards normal when it moves from right to denser medium? There's a basic condition. We can put it here. Similarly, what would be when a ray of light moves from denser to rarer medium will analyze in terms of wavefront. I think I can't. Okay, let's go for another page. There's a boundary.